All right, guys. So here's the second day of rational exponents. All right. So this first example I want to do these problems, this property I want to do when you're dividing. All right, when you're dividing and the bases are the same. All right. So this is what I want to do for these problems. All right. So part A. So if I gave you 7x to the 1/4, and remember, a rational exponent just means that the exponent is a fraction. 7x to the 1/4 over 21x to the 3 halves. All right. Well, if I look at these numbers, I can divide both of them by 7. All right. So 7 divided by 7 gives me that 1. 21 divided by 7 gives me 3. Now I have to look at the exponents. All right. I have to look at the exponents and I have to see which one's bigger. So the 3 halves or the 1/4. Well, in this case, 3 halves is bigger. All right. So since 3 halves is bigger, I know I'm going to do the work in the denominator's position. So it's going to be 3 halves minus 1/4. Remember, when the bases are the same, you're always subtracting. Right? There's no difference from when the exponents are rational or they're whole numbers. Right? You're just going to subtract. So I end up with 1 over 3x, 3 halves minus 1/4 gives me 5 over 4. All right. Remember, use your calculator. Remember, you're using that ABC button. All right. Use the ABC button. And with this one, you're actually going to, your answer, you'll end up with 1 and 1/4. Remember, hit second, hit the ABC button again, and hit equal. And then you'll end up getting 5 over 4. All right. Part B. 26y to the negative 4/3. All right, so I'm gonna throw some negatives at you guys. Make sure that you understand what to do with that. 8y to the negative 11 over 5. All right. Now again, I look at those numbers. Well, I can divide both of those by 2. I can divide both of those numbers by 2. So before I even do anything with the variables, I'm looking right at those numbers. What can I divide them by? All right, so 26 divided by 2 gives me 13. 8 divided by 2 gives me 4. Now, let's focus in. Bases are the same. Remember what we talked about. We're subtracting. All right. Well, which exponent is bigger? Well, if you really look at it, negative 4/3 is actually bigger. So since negative 4/3 is bigger, you're going to do the work up on top. So I'm going to have y to the negative 4/3 minus negative 11 over 5. You notice I'm not changing anything. I'm subtracting. I'm always going to subtract. All right. When the bases are the same and you're dividing, you always subtract. But since this was a negative, all right, it was a negative there, I still include it there. Okay. I'm still including that negative. So I have 13 over 4. And then negative 4 over 3 minus a negative 11 over 5. You do all this same stuff that you did over here with the calculator. Okay. And you end up with 13. So y to the 13 over 15 power. All right. Let's look at C. So I have t to the negative 1/2 over 3t to the negative 1/2. Well, what do you guys remember? There's no number up here. Remember, people in math are lazy. Remember, it's understood to be a 1. All right. So 1 over 3. Can I do anything with that 1 over 3? Absolutely not. So I'm just going to rewrite 1 over 3. Now, if you look at Here the bases are the same, all right? So we know we're dividing, so we know we're gonna subtract. But what do you notice about the exponents? The exponents are exactly the same. So what happens when you're dividing and the everything's exactly the same? This whole thing, this whole thing cancels each other out. So you're left with just 1/3. All right? Because the exponents are exactly the same. Let me erase this mess. All right? Let me erase. Since the exponents are exactly the same, they cancel each other out. All right? So I hope that helps. All right. Let's look at example 2. Now I'm going to start mixing some of the properties. All right? These are going to be mixed. And I'm going to throw some more variables at you. All right? So no crying. All right, just pay attention. If you're not understanding something, please write that down so then you can ask. So 3x to the negative 3 over 4, x to the fourth power, y to the negative 5 over 4. All right, times 6x to the negative 3 over 5. All right. Now I'm looking at this problem. I look at the numerator. All right, I'm looking at that numerator up here, and I notice there's no multiplication yet, but there is a multiplication right there in the denominator. All right, so my attention is going to be immediately to the denominator. All right, that's where my focus is. So since that's where my focus is, I'm just going to rewrite the numerator. All right, all I did was just recopy it. I didn't do anything to it, just recopied it. All right, so since I said my focus was in the denominator, what do I notice? Again, there's no number here. So remember, people in math are lazy. It's understood to be 1. So I have 1 times 6. Well, 1 times 6 just gives me 6. What happens? Bases are the same. All right. What do I do with those exponents? When you're multiplying and the exponents are the same, remember from the last lesson, you add the exponents together. So 4 plus, well, what is this exponent there? Negative 3/5. So negative 3 over 5. And then I have a y, but there's no y over here. Right? So all I'm going to do is just recopy it. Y to the negative 5 over 4. All right. So the denominator, I have to take care of this addition there. All right. So let's take care of that. And at the same time, can I take care of that? Yes, I can divide both of them by 3. All right. So I can take care of that also. So 3 divided by 3 gives me 1. 6 divided by 3 gives me 2. All right. So the numerator still that x to the negative 3/4 stays the same. And then on your calculator, 4 minus that 3 over 5 ends up giving me x to the 17 over 5. All right? Yeah, I know it's an ugly number, but whatever. It doesn't matter. All right. Hanging in there with me, right? Now, I recopy that 1 over 2 because I've already reduced it. I can't do anything with it. But now what happens? I'm dividing, and those bases are the same. All right? So which exponent is bigger? I have a negative 3/4 and I have a positive 17 over 5. Well, positive number, I know that that positive is going to be bigger. So since 17 over 5 is in the denominator position, I'm going to do 17 over 5 minus a negative 3 over 4th. All right, now let's turn our attention to this y. I don't have a y up here, so I don't have to worry about subtracting anything. But what I do have to worry about is I have to worry about that negative exponent. And remember, the last lesson we talked about, if you have a negative exponent, it has to get moved. Since it's in the denominator's position, all right? Since it's down here, I have to move it up to the top. And the exponent becomes positive. All right, so I told you there's going to be mixed problems here. All right, I'm mixing stuff up here. All right, now, sorry, that's supposed to be a 4. What looks like a 9. All right, so now let's take care of this. And it's just calculator work. All right, so I don't want you guys freaking out. So I have this 1y to the positive 5 over 4. I have the 2 down there. And when you do all this work right here on your calculator, you end up with, and it's going to be an ugly number, 83 over 20. All right? Ugly number, but yeah, that's what happens when you're making crap up. Okay? All right, so we good? All right, all I'm doing is mixing stuff up now. I'm trying to give you guys practice. All right, part B. 3t to the 1 over 4 v to the negative 2. Sorry, guys, I don't know what all this crap is happening here. All right, go away. All right, times, having technical difficulties here. 3t to the 5 thirds v to the negative 1 all over 2t to the 0 power v to the negative 7 over 4. All right, again, ugly looking problem. But what do I do with it? All right. I look at that numerator and I'm seeing I have to multiply. All right. I have this multiplication here, so I'm going to be multiplying. So when I multiply, I have two numbers there. All right. So 3 times 3 gives me 9. Well, I look, I have t and another t. What happens when you're multiplying and the bases are the same? Add the exponents. So I have t to the 1/4 power plus 5 thirds power. And then I have v and another v. All right, nothing changes when you're multiplying. You add those exponents. All right. Now I'm looking at the denominator. Okay, so now I'm just going to look at the denominator here. I'm going to drag that 2 down. What do you guys remember about something to the 0 power? This whole thing just becomes a 1. All right. Remember, anything to the 0 power is 1. And I'm going to repeat it a couple of times. All right. Laugh at me if you want. I don't care. Anything to the 0 power is 1. Anything to the 0 power is 1 except 0. Well, I'm assuming t is not 0. So I'm going to say that that is 1. So I actually have 2 times 1. V to the negative 7 over 4. And does anything change there? No, it still ends up being 2. All right. So don't freak out that that you think I'm adding stuff here. All right. So 9t 1 over 4 plus 5 thirds on my calculator, 23 over 12. And then negative 2 plus a negative 1. Hopefully you don't need your calculator there. Negative 3 over 2 v to the negative 7 over 9 power. All right. So we just took this really ugly problem here to begin with. All right. We took that ugly problem there and we were able to break it down a little bit. All right. So now we're not done with this yet. This 9 over 2, I can't do anything with, so I'm just going to leave it alone. 9 over 2. This t, there's no other t's, and the exponent is positive. So it's going to stay right where it is. All right. But now these v's, I do have two of them. I'm dividing. So I have to subtract. But remember, what do I have to do? I have to figure out which one's bigger. Well, in this case, negative 7 over 9. Oh, sorry, that's supposed to be a 4. Yeah, it's supposed to be a 4. I'm sorry, I can't even read my own writing. All right, let's try to rewrite that. I apologize, guys. That was supposed to be a 4. Oh my goodness. See, if we were in class, you guys would be yelling at me because my writing's so sloppy. All right, see, I put a 4 up there. What the hell did I do? I don't know. All right, so I have a negative 3 and a negative 7 over 4. Well, the negative 7 over 4 is actually bigger, so I'm going to do the work in the denominator position. So negative 7 over 4 minus, remember, you're always subtracting, negative 3. All right, so 9 over 2, t to the 23 over 12. And then when you grab your calculator, holy cow, I'm trying to make stuff better and then making it worse. It's supposed to be a 3. 7 over 4 minus a negative 3 gives me v to the 5 over 4 power. All right? It was an ugly one, but I think you guys can handle it. All right, last one. Even uglier. Even uglier. I think you guys are up to the challenge. All right, part C. Last problem. Well, let me give myself a little bit more room here. All right, holy cow. So I have 4x to the 1/2 power y times 3x to the negative 3/2 y to the 4/3 times 2x to the negative 1 y to the negative 1/3. All right? All over 6x to the negative 2/3 y to the negative 4 times x to the 5/4 power y to the negative 3/2 power. All right, we ready for this? I may need a slice of pizza after I do this problem. This one's a long, ugly one. I got to get my energy back up. What the hell? Go away. I don't know what that keeps happening. All right, sorry about that, guys. You know I have issues talking to my computer over here. All right. So somebody's gonna send me some pizza after this. All right. Now I'm looking. The numerator I'm multiplying, and the denominator I'm multiplying. So I'm multiplying in both. All right. So since I'm multiplying in both, let's just start with the numerator. All right. So I'm looking for coefficients. I'm looking for numbers. There's a 4. There's a 3. There's a 2. Multiply all them damn things together. So 4 times 3, 12. 12 times 2 gives me 24. All right? Easy enough so far. Now, variables. I'm looking for variables that are the same. All right? And remember, what happens when you're multiplying and the bases are the same? We add the exponents. So I have 1/2 minus 3/2 minus 1. All right, you know what? I can already imagine some of you guys yelling at me. You said to add. All right. Yeah. I hear you. So plus a negative 3/2 plus a negative 1. All right, better? Good. They'll be yelling at me no more. All right, now I have all these y's that I'm going to be multiplying together. All right? So again, what am I doing? Just combining, I'm just adding the exponents. Here we go again. People in math are lazy. There's no exponent. It's understood to be a 1. So I have 1 plus 4 over 3 plus a negative 1/3. All right, so again, all I did was I just took the exponents from the y's. All right, are we good? Okay, now let's look at the denominator. So I have this 6 here, but there's no number sitting there. Remember, it's understood to be a 1, so I have 6 times 1, which just gives me 6. Now again, looking at the variables, right? I have an x there's another x. Bases are the same. I'm multiplying. So I have negative 2/3 plus 5 over 4. Y and another y to the negative 4 plus a negative 3/2. All right, so get that calculator going. All right, so 24 and 6. I can divide both of those by 6. So I end up with 4 over 1. All right. Now, when you throw all this into your calculator, oh my goodness, what the hell am I doing? All right, x. We end up with, when you throw all that mess into your calculator, you end up with negative 2. And then when you throw all this into your calculator, we end up with y to the second power. All right, not so bad. All right, now the denominator. All right, throw that into your calculator. We end up with x to the 7 over 12 power. Y, throw that into your calculator. We end up with negative 11 over 2. All right, we're good so far? Yes, yes. All right, again, if you have questions, you please make sure that you're writing down specific questions and emailing us. All right, so here's my fraction bar again. I still have this 4 over 1. Now I'm looking at it. Now I'm dividing. All right, now I'm dividing. Again, what have we talked about? When you're dividing, what do? We look to see which exponent is bigger. Well, which exponent is bigger? 7 over 12, because it's positive, this one's negative. So instantly I know that my answer is going to be in the denominator. So 7 over 12 minus a negative 2. Remember, when you're dividing, you subtract. When you're dividing, you're subtracting the exponent. All right, now, which exponent is bigger for the y? Well, the numerator is bigger, so I'm going to put the y up on top. 2 minus a negative 11 over 2. All right? Last step. I know this was an ugly one, so I said somebody owes me some pizza. Throw that into the calculator. Y is equal to, y to the 15 over 2 power. And then you're throwing this into your calculator. X to the 31 over 12 power. All right. Now, technically, do I need to have that 1? No. All right. So some people might want to rewrite them. I would leave it just like this. I would leave the answer just like that, because you guys know I'm lazy. But there's some of you guys, you don't like that 1 in the denominator, so you would probably rewrite it. All right. So hopefully that helps. If you have questions, please make sure you're reaching out to one of us.